Hello, distinguished viewers. Welcome to Simplified Maths Class. Simplified Maths Class it is. Thank you for subscribing to our past videos. And we'll be glad if at the end of the day you still subscribe in case you have not subscribed to any of our videos. Today we'll be going straight to Venn diagrams part 2. Here we are going to be solving problems that involves Venn diagrams. Set problems that involves Venn diagrams, especially three-dimensional, because the last one we did was the one of two-dimensional and there was no time for us to get up to the three-dimensional. So we'll go straight to point three-dimensional problems that involves the solving of set theory by Venn diagrams. Okay, so we have an example on the board, and in this example they said in an icon district society consisting of 290 members, 150 play hockey, 130 play tennis, and 100 play volleyball. And we're given additional information that 60 play hockey and tennis, 55 play hockey and volleyball, 40 play tennis and volleyball. If 42 play games other than the above three, how many icon members play all three games? Hockey and tennis only. Purely hockey. And then at least 2 games. So go straight to point to see how we can handle this three-dimensional problem that involves Venn diagram. Solution. So the first thing we need to do is to bring out the Venn diagram concerning this illustration. Alright, so we'll draft our Venn diagram. Alright, so we have the universal set. We can use this as a universal set, or we can still use the epsilon sign as a universal set. Alright, so that's still the universal set. Okay, so they say then in an icon district, 290 members are in the district society, so the universal set is 290. We've been given that. They say 150 play hockey. So here we have hockey, and then we have 150, and then we have 130 play tennis. Here we have tennis, so we have 130. And then 100 play volleyball. So here we have volleyball, 100. But take note, this 150 that play hockey also play tennis and volleyball. This 130 that play tennis, they are also part of the people that play what? Both hockey and volleyball. And this 100 that play volleyball also play tennis and hockey. Please take note of that. Let's proceed. Now, additional information, 60 play hockey and tennis. Hockey and tennis. So we have 60. Alright, so we have 55 play hockey and volleyball. Hockey and volleyball, we have 55 here. And then 40 play tennis and volleyball. Tennis and volleyball. How many? 40. So we have 40. And then if 42 play games other than the above three, meaning that there are still people in this icon district society that do not play these 3 games, but they are in the district society. How many of them? They are 42. So they'll be written outside here 42. Maybe some of them play other games. Or maybe some of them do not play any game at all. So they are here outside the 3 circles. So the first thing they ask us to find is, they say, how many icon members actually play all 3 games? And so that's what we'll go straight to point to find out all 3 games. Now we have a special formula for computing the universal set. And it's giving us what? The number of the universal set will be equal to the number for the first one, which is number for hockey, plus the number for tennis, plus the number for volleyball. Then we are adding this and this and this. So we subtract their intersections, these 3 intersections. So minus the number where hockey intersects with tennis. We are subtracting that. We also subtract the number where hockey intersects with volleyball. Hockey intersects volleyball. Minus the number where tennis intersects with volleyball. Tennis intersects with volleyball. Now after subtracting those 3, we'll add this, which we don't know for now because they're asking us to find that value. So plus the number where hockey intersects, tennis intersects, volleyball. All 3. So hockey intersection, tennis intersection, volleyball. So we are going to add that portion. And finally add where neither. That means number of hockey union tennis, union volleyball, or complement. Meaning that this portion is for those that do not play any of the three games. That's the number of hockey, union tennis, union volleyball, or complement. So this is the formula. Irrespective of the letters that are being used, follow it that way. The number for this, plus the number for this, plus the number for this, minus here, the intersection, minus this intersection, minus intersection, plus this and plus this. That's all you need to do. So the number of the universal set is given as 290. So we are going to have 290 is equals to number for hockey 150 plus number for tennis 130 plus number for volleyball 100 minus hockey intersecting tennis 60 minus hockey intersecting volleyball 55 minus tennis intersecting volleyball 40 and then plus all the three, which is what we are looking for, x, plus neither of the three, which is 42. So we are having 150 plus this, minus 60 minus 55 minus 40, plus x plus this, as simple as that. So we are going to have 290 will be equals to, so we are going to add all this, subtract this, and then add 42. So we have 150 added to 130, added to 100, minus 60, minus 55, minus 40, and then plus 42. So you're going to have 267, 267 plus x. So we want to find the value of x. It means that 267 plus x gave us 290. That's what we have. 267 plus x is giving us 290. X will be 290, this crosses to be minus 267. That gives our x to be equal to 290 minus 67. 290 minus 267, 290 minus 267. So we are going to have 23. It therefore means that 23 of the members of ICANN in that district society play all three games. That's what it means. So our value of x has given us 23. Meaning that 23 play all three games. Now, after having this, you need to bring out the adjusted Venn diagrams to enable you answer any other question that follows. So from this, we can extract the adjusted Venn diagrams. Watch and see how we are going to do that. Now, in the adjusted Venn diagram, here we have already computed here to be 23x. So it means that our x here will become 23. We have gotten the value of x. So x now is 23. Now watch me. If you want to know how many play hockey and tennis, only purely hockey and tennis, because it means that if you look at where tennis intersects with hockey, are you watching? Where tennis intersects with hockey, it's supposed to be the whole of this that gave that 60. So for you to know purely hockey and tennis, you have to take 60 and subtract 23. So 60 minus 23 will give me what we have here. Alright, so 60 minus 23 will give us 37. So here we are going to have 37. That's what it means. Now watch. Now for us to know what is supposed to be here purely, to be 55 minus 23. So 55 minus 23 will give us 32. So here will be purely 32. And then if you want to know what is here, purely to be 40 minus 23. Alright, that will be 17. So 40 minus 20 will give us 17. So it means that here will be 17. Alright, so which means where hockey intersects with tennis, 37 plus 23, that will give you the previous 60. Alright, and then 32 plus 23 will give you the previous 55. And then 17 plus 23 will give you the previous 50. Now we have adjusted the Venn diagrams. We still need to know what is here now. What is here now? Now you will notice that these three things clashes into hockey. These three things already takes part of hockey. So for us to have purely hockey, we are going to say 150 minus this, and this. 150 minus 37, 23, 32 will give us what will be purely here. So let's do that. So 150 minus 37 minus 23 minus 32 will give us purely here, and that will be 58. So therefore means that purely here we are having 58. We also need what will purely here. That will be 130 minus these three things that are breaching into that circle. So 130 minus 37, 23, 17. Alright, so 130 minus 37 minus 23 minus 17 will give us 53. So here we are going to have purely 53. And then for us to know what will be here purely, it will be 100 minus these three things that are eating into the circle. So we are going to have 100 minus 17 minus 23 minus 32, and we'll have 28. So here will be purely 28. Alright? Now with these adjusted Venn diagrams, if you add every value you have here, it must give you the universal set, which is 290. If we add all the values here, they must give us 290. Let's see if that is true. 58 added to 35 added to 28 added to 32 added to 37 added to 17 and then added to 23 and then finally added to 42. That's 290. That's what you have, which is what you have in the universal set. 58 plus, let's go, 58 plus 53 plus 28 plus 32 plus 17 plus 37 plus 23 plus 42. That gives dot 290. So you have everything you add here must give you back the universal set. That makes you know that what you have is actually correct. Therefore, 23 play all three games. Now, with the adjustment diagrams, it's easy for you to answer any other question that follows, like the I, and the I, because the first one we did I, all three games, which is the X, all three games, which is the 23 we had. So now we need the I, and the I. So that will be very simple because already you have the adjusted Venn diagrams. So they now said how many play hockey and tennis only. I. The number that play hockey and tennis only. Hockey and tennis only. Those that play hockey and tennis only are now 37 in number because we've done the adjustment. So that will be 37 members. Alright, please take note of that. Then the next one, I. Those that play volleyball only. Volleyball only. Number that play volleyball only. Alright, we have done the adjustment, and the number that play volleyball purely 28 by the adjusted Venn diagram. So we have that will be 28 members. And then finally, IV, the last one, they say how many play at least 2 games. Alright, so number that play at least 2 games. At least 2 games means those that play 2 or more games. Those that play purely 2 games or purely 3 games, because the word at least 2 means 2 or more. So those that play purely 2 games. Now, these 2 play purely 2 games, which is 32, plus this one play purely 2 games, which is 37, plus these 2. This one here played purely 2 games, 17. Now it means that these 32 are for those that play purely hockey and volleyball, 32. 37 are those that play purely hockey and tennis, 37. And then 17 are those that play purely tennis and volleyball, which is 17. Since we said at least 2, that's 2 or more, then those that play all 3, which is 23. So we are going to add all that. So 32 plus 37 plus 17 plus 23. That gives us 109. Therefore, 109 members play at least 2 games. That's all. So we've been able to solve this problem that involves 3 Venn diagrams. Please take note of that. It's as simple as that. So whatever problem they give you that involves 3 Venn diagrams, you should be able to do it very fast. All right, so let's go.